Ladies and gentlemen, dear colleagues, dear friends, good evening. It's a distinct pleasure for me today to welcome you back to Monrepos after the restrictions of the last years. Today's Human Roots Award was actually planned for 2020, but we had to postpone it for 2 years. And these last 2 years have been challenging for many of us. And it sort of feels that we are almost back to normal, which actually we're not, because we currently have to face new and even different challenges. The other day I talked to a colleague of ours who regularly joined the award ceremony in the past, and when he talked about 2019, he was already referring to the good old days in Monrepos, and I think this is the perspective that must be actively countered, because we're still human, and what has not changed apparently is our human disposition. Our award ceremony provides an opportunity to celebrate, and that music and dance make humans happy, scientifically proven, not least due to the research of this year's award winner, Michael Tomasello. In fact, the very oldest representations of dance ceremonies come from the 16,000-year-old site of Gönnersdorf, the site because of which we have set up camp with Monrepos here in Neuwied today. Many of you know that with its research agenda, Monrepos has set out on a path that is quite different from other perspectives in Pleistocene archaeology. And we are interested in studying what distinguishes us humans as individuals and what it is that unites us as a species. And this is an agenda we share with many other disciplines, but with some self-consciousness, we hold for ourselves that as archaeologists, we're the only ones who can verify and test hypotheses of these other disciplines, in many cases because we are the custodians of the material archives of the past as a direct expression of human behavior. And this places us, or better to say Pleistocene archaeology, at the intersection of many disciplines, not only the natural sciences, whose object of study is human. And this actually is where the Human Roots Award comes in. With the Human Roots Award, we honor archaeologists or scientists from neighboring disciplines for their achievement in the understanding of human behavioral evolution. With this prize, we aim to promote interdisciplinary scientific dialogue, and we want to raise public awareness of the relevance of our research on the human condition for the future of humankind. And thus it is that we understand our prize not less than a small Nobel Prize for the disciplines of our field. When it comes to the question of what unites us as human beings, there is only one patron for our prize, and that was the founder of the discipline of human ethology, Irenäus Eibl-Eibesfeldt, and who held our patronage until his death in 2018. And it is against this background that I'm particularly pleased today to welcome his descendants Bernolf and also Monika Eibesfeldt. Our first laureate, Richard Dawkins, has taken over the patronage after Irenäus Eibl-Eibesfeldt deceased. With our third laureate, the evolutionary psychologist Robin Dunbar, we now have a common research interest. So I can say quite self-servingly that this annual award ceremony continuously compels us to engage with other disciplines and opens up perspective for us and our research that we share with the awardees in the breakfast debates the morning after the award ceremony. The Human Roots Award for us is, as an institution, is an instrument of continuous learning. And for this opportunity, we would like to express our sincere thanks to Alexandra Busch, the Director General of the Römisch-Germanisches Zentralmuseum, who makes this award ceremony possible. Our prize this year Our prize this year goes to the anthropologist and behavioral scientist Michael Tomasello. And our relationship with Michael Tomasello aptly sums up a quote from Goethe, who said, "Why wander far afield? See, the good lies so near." As a director at the Max Planck Institute of Evolutionary Anthropology in Leipzig, Michael Tomasello was indeed geographically very close to us until his retirement. And we always perceived his research very important, and we always felt the urge to make contact. But as so often in life, we always postponed because Leipzig is not far away, and as we shared project with the archaeology in Leipzig anyhow, we visited very often, but contacting Michael always remained at a declaration of interest. And however, there is a right time for everything, and I believe that with an entire universe of new questions and perspectives, as a research institute, only now we are actually able to apply Michael Tomasello's research on theory of mind or cumulative culture for the interpretation of the archaeological material. And all the more, I'm happy to welcome Michael Tomasello with us today. Now, before my colleague Tamara Dugancic will give the laudatio for Michael Tomasello and afterwards present the award, we would like to play a video message from the patron of the Human Roots Award, Richard Dawkins, who unfortunately cannot be with us today. And with that, I will pass on to Richard.
It's my honor to be patron of the Human Roots Award in succession to Professor Eibl-Eibesfeldt. It has been my pleasure on several occasions to visit Monrepos. The human species differs from other apes in many respects, important respects, language perhaps above all, but other things as well that go with language. And the study of developmental psychology is central to this. Professor Tomasello is a master of this. Unfortunately, I cannot be at Monrepos for this ceremony as I'm in Arizona, but I'm delighted to congratulate Michael Tomasello on winning this award.
Dear guests, dear colleagues, dear friends, and Mike, it is a great honor and privilege to introduce to you this year's laureate of the Human Roots Award, Professor Michael Tomasello. So who is he? Unlike many scientists today, Mike breaks the boundaries of different disciplines, scientific disciplines. So his research is asking these fundamental questions of why are us humans and our lives so different from other animals, and why are we so unique? So he does this primarily from the perspective of developmental and comparative psychology, but he has his foot in many other disciplines where he made outstanding contributions. There are linguistics, primatology, neuroscience, anthropology, biology, but also place to see in archaeology and in the understanding of evolution of human behavior. So as one of his collaborators describes him, he's addicted to discovery. So he kept asking throughout his career, asking new questions, opening up new ideas to explore, and even the ones that might prove him wrong, which is a quality that many scientists actually don't have. So all this makes him a real universal scientist. So it is a high time for him to visit Monrepos, which is an institute of the Leibniz Science Association, named after one of the most prominent universal scientists in the 17th century. So with science becoming more and more specialized, it is very rare to have scientists like this nowadays. So Mike is visiting us from North Carolina, where he's currently professor of psychology and neuroscience at Duke University. And Duke is actually his alma mater, So where he started this idea and where he got very interested in animals, especially chimpanzees and children, and in a way, very much in a way that interested in how and fascinated by chimps on how they differ, but also they're very similar to us at the same time. So it is a comparison of chimpanzees and humans that is his angle in approaching this question of understanding human uniqueness. So this outlines his professional trajectory. So luckily, while he was at Emory University in Atlanta, Georgia, and in Leipzig at Max Planck Institute, he was either affiliated or co-directed in a primate center. So he was basically in a perfect position to directly compare and study chimpanzees and children. And the extent of that research of him and his team was very vast. So they were studying social cognition, cooperative thinking, helping, social norms, morality, language acquisition, gestural communication, imitation, learning, spatial cognition in primates, etc., etc., even the cognition of dogs. And in all of these fields, they make really groundbreaking results. So with such an overarching question of what it means to be human, and making these contributions in many different scientific disciplines, it's no wonder that his ever-growing publication records that currently numbers over 700 scientific papers and books that he wrote, co-authored, or edited. And they're widely cited, nearly 190,000 times. So all these publications make Mike one of the 120 most cited and most influential scientists alive. And this, by the way, citation score is even higher than some of the recent Nobel Prize winners. So all in all, it's pretty impressive. And his books are translated in many languages, including German, and we have provided some books for you that you can purchase later after his talk, and he will be happy to sign these books. You can see some of them. Most of them are also translated in many other languages. So Human Roots Award is currently the last of his awards that he has been decorated so far, and since the list is very long, as you know. So let us return to the research that brought him all this recognition. So as I said, in searching for what makes us human, he takes this comparative view of humans and chimpanzees, our closest relatives. So we all know that we share a lot with them, especially genetically speaking. Yet only one of these species is on the verge of extinction, while the other one is currently numbering population of 8 billion, has a complex culture, technology, symbols, institutions, and seem to be striving, but also doing a lot of harm along the way. So where are these differences actually coming from? So Mike takes this experimental perspective where he's looking at similarities. So what are the things that we share with chimpanzees? And then he outlines this baseline of primate cognition. And then he looks at differences, and especially where even children excel compared to chimpanzees. And what he concluded is that it is social cognition that sets us apart. So he doesn't agree with this, say, general intelligence hypothesis that claims that humans are just smarter in all aspects than any other animal or chimpanzees. What him and his colleagues developed is the cultural intelligence hypothesis, saying that humans are especially mastering cultural and social domains, cognition in these two domains. So we evolved these cognitive capacities, and they actually appear, as he showed, early in childhood, and are always expressed in cultural contexts. So Mike will tell us more about it, but these are some of these differences. So a few aspects that we actually differ from them. So I'll just name a few. So let's say a theory of mind, which is how do we understand others around? So chimps can understand that our individuals have goals. However, even human children are taking that to another level. They would know that one has different views, opinions, or emotions that can be different from them, they can be different from reality. They can also use them in a social context and so also like act around the common goals with them, and they can share it with others. Chimpanzees do learn socially, but never in a complex way through teaching and imitation, like human do that, especially children. They're also, because even in learning, they're very individualist, but also in cooperation. So they will do things cooperatively, but usually only for their own benefit, for their gain. So they're pretty selfish. While even children are very cooperative, they're team players at a very young age. And this is what he refers to as humans being hyper-cooperative. They would also love to, children, they really conform to social norms. They get very upset if you break the rules. But the thing is that what Mike showed us is that what underlies all these cognitive capacities is shared attention and intention. And what is that? So if I tell you, look, there's a champagne over there. So most of you would actually look over there, even if I didn't say champagne. But chimps would not, because they just don't. They just have no idea what you're trying to do and what you're trying to say. So for him, this is a feature that is a proper, let's say, upgrade from a primate cognition. And it is the basic of all the human institutions, language, conventions, norms, and group identity. And down the line, it also enables cumulative culture. And this is one of the topics of Mike's work. And that is a uniquely human culture that cannot exist without previous knowledge of our fellow humans. So indeed, that means that we are standing on the shoulders of giants. This is a quote that you can see in Monrepos at a few places, and that many researchers have been rephrasing Descartes via Newton, etc. So in a thought experiment that Mike often cites, if we have a human, a child human, alone on an island, raised on an island, even with chimps, how would they behave? They would probably behave like a chimp. But the cognitive capacities are there. They just have to be triggered. They just have to be exercised within the social context. So that individual, without any accumulated knowledge, any cultural item, let's say the phones in your bags, space shuttles, elaborate medicine, it would be beyond what that individual can do on their own on that island, and that's what cumulative culture is. Also, Mike has proposed in his work that what underlies all this special, let's call it special smarts, the social and cultural smartness of humans, is cooperation. So there would be no culture and no shared intention in humans if there was no capability to cooperate. So no, this deep sense of us, of groups, which is the ability that's already present in very young children. So Mike's work looks at comparisons side by side of chimpanzees and humans. But these cognitive abilities that he's defining, including cumulative culture and hyper-cooperation, they all have their deep roots in the Paleolithic past. And these are all topics that we are actually addressing in research at MonRepos. But we are interested in learning on when and how these abilities emerge. So what we are doing here, we are studying the origins and changes in soul to technology and culture in general. We ask how humans in the past innovated, how they transmitted that knowledge, and then we compare them even with tool use in monkeys. We look at hunting practices and how hunter-gatherers and our ancestors became such a collaborative foragers. Also, we look at emergence of social rules and regulations or norms and use of symbols in early human societies. So it is actually no surprise that our main research topic shares the name with Mike's recent book, Becoming Human. But all these questions are actually timeless. So his research is very much relevant for the present in comparing the species, for our past that we are trying to understand, but also the future. So he's telling us that humans evolved to cooperate, and that is where we are very unique. And that's a very powerful idea. There are days where some of us question then how cooperative either children or adults humans are, especially when we see our toddlers being reluctant to comply with sharing is caring, etc. But more importantly, we are witnessing nowadays, and actually since the end of the Paleolithic, how uncooperative humans can be. With all the power relationship, property issues, the stories about common enemy, conflicts, etc. So one may wonder, are we really that cooperative? And this is where comparative studies by Mike come into play. They bring some perspective. And this is very well illustrated by his usual response when someone asks him this or makes such comments. So he would say, oh, you have the wrong baseline. You should hang around chimpanzees sometimes. So overall, Mike's work teaches us what human condition is. It helps us to understand how we evolved, but it also comes with this positive outlook and optimism about us humans and our society. And it should really encourage us to put those collaborative abilities in action. So we are very excited to decorate him with this award. So before I give stage to Mike, let me hand you the prize. You're happy to open, show. Congratulations.
Oh my God.
Congratulations.
Well, thank you, Tamara. I'm not sure I need to give a talk because she did such a great job of summarizing my research. So you already have the idea. And I want to say what a great honor it is to receive this award. And so thank you, Sabina, and thank you, Olaf, for all of your hospitality and for this award. And I've just learned so much in the last couple of days. Our hour-long trip in the traffic from Koblenz yesterday and all this morning, and it's a great honor, and to meet this guy also. Yes, Henry, thank you. Okay, so anyway, thank you again, and this place, they talk about here human behavioral evolution, and there really aren't many places that are thinking about behavioral evolution. They're thinking about stones and bones and stuff just on their own and not what they mean about human behavior. So that's why I find this among the most interesting places anywhere. So as Tamara has framed it so well, I'm interested in what makes humans human. My research is on human children and on great apes, but I like to think about human evolution. I like to think about where these things came from. And so all the way when we started in Leipzig, 1998, I already had started with a working hypothesis based on my previous research and theoretical work. The working hypothesis was that the major differences, not all differences, but the major differences in humans and other apes are not in the, and I'm a psychologist, so I mean from a psychological point of view, not genetics or physics or whatever, in psychology. The major differences are not in individual psychology, but in the social psychological mechanisms evolved for cooperation and culture. And I think Tamara mentioned my favorite metaphor of a child on a desert island. What would a child on a desert island who had no social interaction with anyone when they grew up, what would they know about math? Hardly anything. What would they know about, would they invent a language on their own without another person there? No. No books, no pictures. What would they know about dinosaurs? Nothing. What would they know about ancient civilizations? Nothing. Right? We learn all this from other people. So we are adapted to do these things with others. All of humans' greatest inventions, none of them are due to an individual doing it on their own. They are in a tradition, and they're building on a tradition, and they're collaborating with others. So that's the idea. The things that really made it so hard for people to believe when Darwin proposed his theory, what made it so hard for people to believe that it applied to humans is because, Elizabethan England had, the symphony and the telescopes and Parliament, and there were these chimpanzees out in the jungle. How can that be? Right? It's not individual. It's because we pool our cognitive resources together, and that's what I'm going to try to demonstrate to you today, this evening. And so I like to use my research. I don't study human evolution directly, but I want to use my research to think about reconstructing the evolution of uniquely human psychology, comparative experiments with human children and great apes, some human evolution, but very general, okay? I really only need 2 points here. I need collaborative foraging and I need cultural organization. That's all I really need to sort of draw the big picture I want to draw, and you'll see what I mean by that. And ontogeny is a hint. And I'm calling it a hint because we all know that the ontogenetic sequence does not recapitulate evolution, but a lot of times you can see an ordering of things in human development that suggests what might have been the order in human evolution, right? Because for example, one of them is foundational and the other one builds on it. Right? And so if that's what happens in human development, they have to develop some skills and then they build on them. Well, maybe that's what happened in evolution also. So that's why I say it's a hint. It's not direct evidence of anything really, but it's a hint because these are the adaptations that occurred in human evolution are being expressed in ontogeny today, in our children today. And so they don't have to appear in the same order, but it may be. So I'm going to say a lot today about what differentiates humans and great apes. And so I'm going to keep saying great apes don't do this and they can't do this. And I want to start out by saying that's only one half of the picture. Most of our research with great apes, we're trying to establish all the incredibly clever things that they can do. I'm just not going to talk about them tonight. So here are some of them. They, on a very general level, they can perceive and remember things much like humans. Their memory is better than yours and mine for a lot of things. They understand basics of spatio-temporal world and causality, the causality of tools and what's a good tool for a causal problem and what's not. They recognize other individuals. They form relationships with other individuals. They recognize third-party relations. They know that these guys are friends and this guy's dominant to that guy. They recognize third-party relations. They form relationships themselves. They read the goals, emotions, and perceptions of others, meaning they know what others are what they're trying to do on an individual level, what their other one is perceiving. So they have all of this as individuals, but they are doing this in a mainly competitive world. Now, they do have some cooperation, and I'll mention that, and you'll see some of it in a minute. But they're not really built for human-like social coordination. And what do I mean by human-like social coordination? Human culture has, from a psychological point of view, I think we can think about it as having two dimensions. One of them is coordination, and that's in the moment. Collaboration, working together, communication, where we're coordinating, you do this, I'll do this, and we coordinate together. Humans do that in some unique ways. Chimpanzees do it to some degree as well, but humans do that in some unique ways. And transmission, which we can think about as diachronic. So this synchronic collaboration and coordination and diachronic transmission. And again, chimpanzees do some social learning from one another, but humans do it in some unique ways. So let's think about these two dimensions, and I think here's the hypothesis that I proposed for the first time in a current anthropology paper some dozen years ago or so, or 10 years ago or so. So the idea is that chimpanzee social life is built around competition. Now, yes, they groom one another and they do some cooperative things, but mainly it's about competition. I've done just a very small amount of field work, but they travel around in little groups, and when they find food, they scramble to see who can get there first, or the dominant scares away the subordinate before they take it. So they're competing over food all the time. They compete over mates all the time. And so this is 6 million years ago was the last common ancestor between humans and chimpanzees and bonobos. So I'm going to think of chimpanzees as kind of a model species for the last common ancestor 6 million years ago. Of course, they've changed since then, and so but they're the best thing we have living for that common for that last common ancestor. And then I'm going to propose to you two major steps. And we talked about this morning. They're both going all the time, okay? So chimpanzees already do some collaborative things. They already do some social learning kinds of things. But there are two big leaps that happen in human evolution, I think. And the time frames we're going to have to be very loose about. And the first one is that humans start collaborating in some new ways. So they are, I'm going to show you some experiments of young children to demonstrate what I mean, but they are coordinating as individuals with one another in some new ways. This is very likely coming from evolutionarily new ways of coordinating and communicating and collaborating in early humans when they start collaborative foraging. That's the most likely place for it, the kind of thing that they study here so intensively. So I've called this joint intentionality because shared intentionality is the general term where we have a shared intention. We intend to do something together. We have a goal. We are paying attention to something together. We have some common knowledge. So we act as a unit. I have a new book that was shown up there about the evolution of agency. I call it we agency. We act as a single agent together is what collaboration is. And what happens in this first step is joint intentionality between individuals. And that's this coordination. And what happens in the second step is what I've called collective intentionality in the group. So we have normative conformity of conventions, norms, institutions. These are the things that bind us together in groups. I don't know about the dates, but in any case, this is somewhere back here, somewhere, and I think I'm going to get some disagreement here, but this is modern humans or something like that, and we'll talk about that in the morning. So I will defer to you guys on the dates if we can work out what actually happened. Okay, so let's talk about each of them just a little bit. Collaboration. Chimpanzees do one thing collaboratively that is in the direction of humans that we have to talk about here. So some of you may have heard they do this kind of group hunting of monkeys. And I've seen it in my 1 month of field work. I saw 3 occasions of it. And what happens is the males are the ones that hunt, and there's several males, if they happen to be together, opportunistically, if a monkey, red colobus monkey typically, is away from its group, so he's sort of at risk, one of the chimps chases, and then the monkey starts running. They go up the trees, the monkey starts crawling across, another one comes over and says, oh gosh, I'll head him off over here. And another one says, oh, there's an escape route. He might go out. And they go over there. So each one of them is acting very intelligently to try to get the monkey. And another one says, oh, gosh, all the good places are taken. I'll wait on the ground and hope he falls. Right? But each one of them's doing it for themselves. They're in it for themselves. And you've seen lions do something somewhat similar. Right? So they encircle it, but they're encircling it because each of them is trying to maximize their own individual opportunity to catch the monkey. So compared to human collaborative foraging, this is optional, meaning they don't have to do it. So there's weak natural selection on it. There's no partner choice, and this is going to be key in the human evolutionary story, is with humans, if you're not a good collaborator, nobody will choose you as a partner. And so you don't get to play the game. You don't get to engage in collaborative foraging because everybody pushes you away. Chimps don't do that. They don't exclude free riders. They don't choose the best partners. There's no partner choice. No planning or communication. It's all opportunistic. They get excited and they scream, and you can hear the guy screaming. You know that the monkey's probably close over there, but he's not intending to communicate to you, hey, the monkey's over here. The food sharing at the end, it's a melee at the end. Okay, they're all grabbing at it and whatever, all right, and they're sharing in the sense that it's called tolerated theft. The guy lets you take it. And why does he let you take it? Because if I stop and fight you for the carcass, then she's going to get it while we're fighting. She's going to get it. So it makes no sense to fight. Everybody just gets what they can. So there's no real sharing. It's only called sometimes sharing under pressure. And again, they don't exclude free riders. So, and in humans, if we've worked all day to forage together collaboratively to down a big game or something, and you've been taking a nap all afternoon, and you come up and say, oh, okay, I think I'll share in this with you. We say, think again. We've been working all day on this. So you have to exclude free riders for cooperation to evolve, because there has to be some benefit to cooperating. You can't have people who don't cooperate benefiting to the same degree that those who do. So anyway, this is what they do that's closest. And what I think happened, again, these guys here are the experts, and I pulled these randomly off of the internet, so I hope they're not too misrepresentative. But I think what happened somewhere back there is in early, a million, or I think you had 1.7 million up there somewhere, obligate collaborative foraging with interdependence, meaning we depend on one another. It's obligate, meaning that maybe you can get some other things without collaborating, but the main stuff you need to get is collaborative, and we're interdependent with one another, and there's partner choice. So if you're not a good communicator, I don't want you as a partner. If you steal all the food at the end, I don't want you as a partner. And if nobody wants you as a partner, you're out. So this is actually called social selection. On analogy with natural selection is typically the environment, and social selection means nobody in your group wants to have anything to do with you. In humans, you're a goner if nobody wants to have anything to do with you. So there's selection for it. And so shared intentionality, I call it joint intentionality when it's collaborative, is my theoretical construct. In individual intentionality, the individuals are going for food, the chimp's going for food on their own. They travel in a group, but then they go on their own. And even when they're in this group hunting, each one of them is trying to get the monkey on its own, and they wouldn't share it if they didn't have to. They're acting intentionally, they're reading others' intentions, and when they're competing, they're trying to hide intentions. If in chasing the monkey, one of them captures it and the other ones aren't around, they'll try to go somewhere quick and eat it before the others get there. And with joint intentionality, we share intentions for mutual benefit, we share the food at the end, we coordinate, and we advertise our intentions. I tell you what I'm going to do because I need to help you collaborate with me in the best way possible. And let me show you, this is actually a home movie when my daughter took 9-month birthday, and I have coined the term somewhere in the literature, 9-month revolution, when this joint intentionality starts. And let me show you what I mean. I'm going to show you a chimpanzee in a minute so you can compare. So 9-month-old is barely walking, poorly walking, not talking at all. So before all of that stuff, and I want you to watch, because it was our 9-month birthday, I said, let's do something collaborative and see what happens. And I'm going to initiate a game of rolling a ball back and forth. All right, and I roll it to her, and I'm very excited that she rolls it back to me. I'm going, oh my goodness, the sibling is on the camera, and I'm saying, oh God, you know. And she's going, now watch where she's looking. Watch her look. See, she looks to me, all right, and then she rolls it back and looks up to my face. That one came back to her. It didn't work for her. She looks up to the face. Okay, so it's constantly monitoring. So we call it shared intentionality because we're sharing attention. We're doing this together. We are playing this game. You could never get a chimp to do this. They just wouldn't. It just wouldn't be. And you're going to see the chimp in a minute. And here's a communicative act that this happens very quickly. So watch very carefully down here. That human babies do at around 9 months or 1 year. That's it. Okay. So what's the point? Most animal communication, almost all animal communication, is they're trying to get you to do something. And this is just, isn't this cool? You know, that's it. Okay, look, oh yeah, oh great. Right? And we actually have done a study where we wait for the child to point at something, and they point at it, and we just look at it like this, and they're not very happy about that. They want you to say, oh great, okay. They want you to share it with them. So sharing enthusiasm, sharing attention. And then here's the classic book reading case. This is 9 months to the day. This is done, you can see she's wearing the same clothes. And then she looks back to mom. See, she looks back. All right, because we're referencing together, we're looking at the book together. Now here's a chimp that I found. This is a human-raised chimp. She's 3 years old, Annette, and she's interacting with the human. Now watch, the human's going to try to engage her with the ball. So I chose some scenes where it was similar to the other one. And now she's trying to engage her with the ball. And Annette is interested in the ball. She likes playing with it. But notice she's not doing anything like rolling it to her or handing it to her or showing it to her or sharing it with her. She's playing with it by herself. Okay. All right, now a little clip there. Now we're going to do some book reading. And again, Annette likes the pictures in the book. But she doesn't look back at the adult, at the human. She doesn't try to point at anything. She doesn't share anything about it. She's just looking at the book. All right. And you get the idea. And if you're thinking, well, gosh, that's a human-raised ape, watch, here's a food situation. Now imagine if you went and looked in a park at a mother, a human mother and her child. Think about how the food sharing would happen. Mom would offer the child some, the child would request some. Here's the way it happens in chimps. Mom has an apple, the baby wants some apple. These are captive guys. And mom is looking away, you know, the kid's just sort of grabbing it and stealing. Mom is allowing her to do it, but mom is not offering it. And in fact, once chimpanzee babies wean, they're on their own to get food. Mom doesn't offer them food. Mom doesn't get food for them. From the time they wean, they're on their own. Right? And, you know, I don't know about your kids, but my kids aren't on their own. They still have the credit card when they're in college. So, and actually, there's studies of hunter-gatherers that in hunter-gatherer cultures, youngsters are not bringing in more calories than they're consuming until they're 16 or 17 years old. So this is not just modern culture. This is humans across the board. The youngsters are supported by adults in everything, and in chimps they're on their own from age 4 or 5. So this is a real dimension of collaboration as well. We even have a physiological characteristic, a morphological characteristic that some people have said is part of this collaborative mindset. Of the roughly 200 species of primates, all of them have eyes like this, where if they're looking straight ahead, you can't see any white. They have white sclera, but it's behind, and you can only see it if they look to the side. And only one has this. And people have talked about this as being, if we're collaborating, we're carrying something together, we're working on something together, it's in my interest that you see where I'm looking. All right? I'm trying to advertise to you what I'm thinking, where I'm looking, so you can coordinate with it. If we're competing, I don't want you to. I don't want you to know what I'm thinking. I don't want you to know where I'm looking, so I can exploit it. So this is something I talked with Svante Pääbo at our institute about, could we find the genes for this and know when this happened, but no candidate genes available, so for the moment, no. So let's look at collaboration in young children, so I can try to contrast that with the apes, and both in terms of their coordination and in terms of sharing the spoils at the end. So this is a little task. Felix Warneken did the research, and this tube comes apart, and there's a toy inside. The child knows there's a toy inside, and part of the experiment is that Felix is going to be difficult on purpose. And we want to see what the child does if he's difficult. Right? And see, he's pointing and saying, pull your thing, pull your thing. So he's using this pointing gesture. Now, children, young human children point like clockwork. All right, all the time I have friends who have babies, and I ask, how old are these? 8 months. Okay, a month or two to go, they're going to start pointing about 10, 11 months of age, and they all do. And there's a lot of good data on that. It's a very robust phenomenon in children, across cultures, I should say. And I actually have proposed that this, and it's uniquely human. Other species don't point. Our little canine friends here have some special characteristics because they evolved to interact with humans, but in their natural communication with others, humans are the only ones that point. And the pointing gesture is used evolutionarily, as my proposal, to help coordinate activities, just like that child was doing. And you're going to see this child doing the same thing. This child is 18 months. This is Felix again. And this was actually a study of helping. But we were kind of playing around. This was actually a pilot subject. We were playing around. Okay, and to show the cooperativeness. But watch for the point. He's going to say, they go there. Okay? And then the door's closed, and he pulls the door, and he looks back and says, they go there. So he's telling him how to play his role. Okay? This is real coordination. Right? And now... And so now, last time this child waited for him to have trouble and then helped him. Now he anticipates the whole thing. This is an 18-month-old, anticipates the whole thing, and again tells him how to play his role. Put him there. Okay? Okay. And now he's going to initiate the ending sequence. Okay. Chimpanzees are 10 times more competent than this little toddler who can't feed himself, who can't go outside by himself, who can't do anything on his own. All right? Chimpanzees are way, way more competent as agentive individuals in the world. But they can't coordinate with another individual like this at all. Of anticipating what the other one's going to do, telling the other one how to play his role. They have a predisposition for coordinating and acting together as an agent with other individuals already when they can't even feed themselves. Okay, so this is really, you're already seeing it here. And again, chimps, no. Now, chimps do collaborate some, and I'm going to show you this now, but I'm going to show you the issue with it. So we did some studies showing that they do collaborate under some circumstances. So this is an apparatus where if you pull the rope by yourself, it's threaded through here, so it just pulls out. You have to wait for the other guy, and then you pull it together. And you're going to see that the chimp knows to do this. This was done for a TV thing, and it's actually 2 experiments together. But so she knows if she pulls, it's going to not work. So she goes and opens the door for her partner, and they pull. But notice, we've separated the food for them. We've solved the problem of how to divide the spoils ahead of time. Now, being tricky psychologists, we're going to put the food in the middle and see what happens. So she goes to get the partner. The one that you're watching here is dominant. The other one knows what's going to happen, so she's unenthusiastic.
But the dominant chimpanzee grabs all the food.
Okay, so what happens on the next trial? Cooperation breaks down, right? They can't keep going. You can't cooperate if both of you don't get something out of it, right? And now let's compare that to human children. And these are little 3-year-olds from a German Leipzig Kita. And it's in the middle, 4 Gummibärchen, right here in the middle. All right, so I'm not showing you when they're separated. I'm only showing you when they're in the middle. And they know how to play this little apparatus. And I chose this one because this little boy acts like the chimp. He's coming over here, but he doesn't take them all. And this little boy, he says, I don't have any on my side. And he comes over. He starts to take all of them that are left. He says, no. It's unthinkable that 2 chimps could sit there this close together with food, reaching for food. That's not possible. They would be fighting. And they can do this all day long. As many gummy bears as their parents will let them have, that's how long they can do it. Okay? And not only that, notice that if one of them starts to be a little selfish, the other one objects. No. And he relents. And they divide it 2 by 2. Even 3-year-olds can tell 2 versus 2 is the same and anything else is not. They divide it 2 by 2 almost every time. And if one of them tries to sneak something and the other one objects, he almost always gives it up. And some of you may be saying, well, I have a 3-year-old at home and my 3-year-old doesn't share. Okay, so you have some special kids here. No. The issue is no 3-year-olds share very well if they have it in their grubby little hands, okay? So if they have stuff and you say, share some with your friend, they don't want to share, right? Because they've got it already. But we found a situation where if they collaborate, all right, they come in the room and these are actually marbles, and the marbles are a reward because there's a little, what we call a pling machine here. They're going to get the marble and they put it, it goes pling, and believe it or not, kids are really excited about doing this. They work very hard to get marbles to play the pling machine. So we're gonna rig it. We're gonna do the situation where nobody has these in their possession. You don't have to give up anything. The question is how to divide them. But we're gonna, being tricky psychologists, we're gonna do this in a special way. Now watch what happens. Whoops! 3 to one side, 1 to the other. Almost every single child gives up one of them. And it's not just that they're being generous because they didn't give all of them to the other guy. They only give 1 so that we both have 2. So the title of this paper is actually Collaboration Facilitates Equal Sharing in Children, but you might guess, not chimpanzees. So I won't go into the details of it, but chimps aren't very good at sharing food anyway. But we tried to make it where in some cases it was a collaborative partner who helped generate the food, and in another case it wasn't, and they didn't care. It didn't matter. They shared very little in either case, even if the other guy was a collaborator. Right? So some people have asked me, if collaboration is so useful in human evolution, why haven't chimps evolved collaboration? And the simple answer is they haven't gone through this evolutionary process where they need to collaboratively forage with partner choice. But the real sticking point is, step one is you've got to be able to be tolerant around food and share food. And if you can't be tolerant around food and share food, chimpanzees and other great apes, including bonobos, who I know are a little bit more cooperative but as well, they are evolved to resolve disputes over food by dominance, as are many animals. And you have to get rid of that if you're going to really be a collaborator and share the food. You have to get rid of let the dominant take everything they can. In captive chimpanzees, when you bring them in at night and give them dinner, you have to pile a big pile of food in one of the indoor cages, so the dominant will go there, and then you spread out the food in the other cages, or else the dominant would take all the food that you give them at night. You have to spread it apart. That's just their nature. That's the way they are. Humans have evolved in a different direction because we need to collaborate, and only individuals who can share the food in a reasonable way are going to have good partners. Otherwise, people are going to choose against them, and they're not going to have partners. Okay, so this is the evolution of the ability to coordinate with others. There are a lot of cognitive processes. I didn't delve into too much, but a lot of the communication is going to be about me imagining what you think about what I'm thinking, that kind of recursive coordination. There are a lot of things that happen in this kind of uniquely human form of collaboration. Also, when the child objects, I think it's a very interesting process where we're doing it together, but you're not doing your part. I call you out on it, and chimps don't do that. I didn't show you, but we have one study where if the partner doesn't do what they're supposed to do, the chimps just kind of go, people are crazy, chimps are crazy, they didn't do it, so what? The children go, hey, that's not fair. Why didn't you do your part, right? So they have a sense that we said we were going to do it together. So that's a mechanism for facilitating cooperation that you don't see in other apes. Okay, cultural transmission. Once again, I want to say culture and collective intentionality. There's a group-mindedness, that's the key. The second step is group-minded. Yes, they've been living in groups all along. Chimps live in groups. Humans have always lived in groups. But there's a change into a group-minded psychology. Conventions and norms, and these are enforced third party. You will see it. That is, if you break the rule, I enforce it. Group identity, in-group favoritism, in-group, out-group psychology. Distributive justice in the culture at large, which is at least an ideal. We may not be very good at it, but it's at least an ideal. And cumulative cultural transmission, which I will explain what I mean by that in just 1 second. So one of the ways that I got into this whole line of research, I did research with young children, and I was at a university that had a primate center just by chance, and some people started talking about chimpanzee culture. And this is actually from an early publication of mine where I documented all the different places where something more or less unique was done with chimps. So you all have heard of Jane Goodall's termite fishing. Only some groups of chimpanzees fish for termites, not all of them. There's a nut cracking behavior that chimps engage in West Africa, but not in East Africa. So they have these population-specific behaviors, but a lot of them are driven by the environment. So the reason they don't crack nuts over here is because those nuts aren't there. That nuts don't grow over there. The reason they don't fish for termites over here is because the termite mounds are very soft, and they just knock them over and grab the termites. They don't need to fish. So a lot of the population differences are not what we think of as culturally transmitted, but they are just individual adaptations to the local conditions. And so, gosh, 20 years ago now, that's, oh gosh, is it really 30 years ago? Oh my gosh. Okay. So I proposed this idea of the Ratchet Effect, the cumulative culture. And so here's the idea. Imagine, I couldn't find a group thing like this of early humans. So imagine these are early humans, not people in suits. So everybody's using rocks to do whatever, to perform some task. And then maybe it's only one individual. One individual invents some brilliant invention that makes it much more effective. Now, it could be a group of them that figured this out, but let's, for the sake of argument, just say one individual figures it out. What happens in humans? Everybody gets it immediately. Everybody knows a good idea when they see one. They can see it's better than what they're doing. So they adopt it immediately. So now, one genius the whole group's got it. Now, it can be a completely different genius. It can be generations later. And this guy, now we're skipping many tens of thousands of years here, hundreds of thousands probably. Yes, hundreds of thousands. There's iron or whatever, and somebody puts that together, and what happens there? Well, of course, everybody gets it. And it's a different individual that made the thing. So, and then let's go ahead and play it out till the end, then you get something like that. Okay, and that's, of course, a cultural invention with a history and collaborative invention and all of that. So the idea is that this is not an individual process. This is a group process where each individual benefits from the inventions of every individual, of all the other individuals. Jane Goodall made a comment one time in one of her papers saying she thought that the chimps did a lot more clever things than we were aware of because they might do them on their own and we didn't observe them and then they're gone. That doesn't happen in humans hardly at all, because if somebody does something really clever, everybody else grabs it immediately. In the modern world, if you do something very clever, you have to take out a patent and protect it from other people, or they'll make a profit off of it, right? So with the chimps, there's not this immediate transmission in the group. And so you can't have this building up in complexity over time. And so what we have in the Ratchet Effect is that it took us many tens of thousands of years of mathematics to invent probability theory. It only comes in like the 16th century or something where we have probability theory, and our kids today get it in 7th grade and they just, they learn it or whatever. So we have these inventions. Our kids, it took all these years for this laptop, and our kids just get it like it's a natural piece of the world. So the ratchet is that each new generation gets the modern thing as if it's normal, and then they can have a new modification or improvement, and then the next generation gets the new and improved version. So we ratchet up over time. If people don't know what the ratchet is, I know from my German before, there's a ratchet wrench, and it's called something like a Hebe. Sorry? Okay, Wagenheber. Okay. And it only goes in one direction, right? You get it, and then when you go back, it stays in place, and then whoop, it goes. So the ratchet effect is it's going up because this invention stays in place because it's doing a good job until somebody gives the improvement, and then it ratchets up a click. So humans, and so this is the mechanism why Charles Darwin's contemporaries had the British Parliament, and they had telescopes, and they had poetry. Not because one individual did it, because there's a whole history of Western civilization leading to those things. Right? One of the key components of this is that humans teach their children. People are all the time trying to see things in the wild that they think are teaching. I don't go for any of them really. Christoph Bosch, my colleague in Leipzig, has an example of something he thinks is teaching in chimps, but I don't really buy it. But this is an everyday thing in all cultures of the world. It happens differently in different cultures. But here's an example of what I want to show you is that she's teaching, she's addressing the child communicatively. She's saying, here, I'm going to show you how to do this. And this is like the little child holding up the thing and showing his dad. I'm going to show you how to do this. And this is a light that turns on when you press it. And if you give it to the child on her own, she'll press it with her hand like this. And we've already tested that. So this is how she naturally opens it. And now the adult is going to use the ball to do it. Okay? So we know the child's natural tendency is just to use her hand, but she saw the adult use the ball. And so, of course, she's going to use the ball. And and she looks up to her face, right? Is this how you do it? All right? All right? And now, just in case, you're going to see her. So she's successful doing that. She's proud of herself for doing that. And now, Tanya is going to do it with her wrist, and she's just going to switch and do it another way. Okay? You do it like the adults do it. That's all. And I'll show you and children themselves. I think the basis of teaching, and this is why I think the cooperation part is first, and the culture and cultural transmission part is second, is because teaching is really a similar thing to that child show. It's showing somebody else something with the goal that they learn it. So this is a 24-month-old girl, and she knows how to operate this little apparatus here, and a puppet is struggling and having problems. We have her behind the plexiglass so she won't go help him immediately, but so since she can't go there, she's going to show him how to do it. Okay? She's showing him how to do it. This is teaching. Here's how you do it, like this. All right? So this coordinative communication is an outgrowth, this kind of teaching, showing and teaching, and this doesn't require language. There are kinds of teaching and pedagogy that require language. This is the simplest form, and it requires this kind of cooperative communication where you're just showing somebody something. But in this case, you're showing them with the goal that they learn how to do it. So that's the teaching side, and only humans really do any teaching. The only other great example of teaching in the natural world is lions, and they're not any great examples of teaching in non-human primates. So this is a little task where they didn't do this together, they did it separately, but the chimp and the kid in separate experiments saw success if they stuck something in this hole in an apparatus and food came out. So they were successful doing this. All right, and then each of them separately saw 3 other individuals now being successful putting something in the other hole. And these were conspecific. So these were 3 other chimps that we had trained to do it here. So this guy is successful here. Now he sees 3 other chimps being successful there. They never change, ever. Okay? Once they find a use, that's very smart, right? Once you find a way that works, you stick with it. That's an important strategy for all of us. The children, not necessarily more clever, but they see the same thing. They're successful themselves. They see 3 other kids doing it here. 60% of them try the new way. Why not? You know? So it's not more intelligent or more clever. It's just more social. Right? So they're learning. They're more attuned to what other people are doing, and they're ready to do it the way other people do it. And it's even slightly more than that. This is, we explained to the kid, this is a 5-year-old, and we explained to this little girl that our goal here, we're going to play this game where we have to move the rice out of this big container over to this bucket. And we've got a little cup, one of these little fold-em cups that we're going to do it with, and the adult says, we're going to move the rice over here, okay? I'll show you how. And then here's how she shows her how. Here's the demonstration. Okay? So she does her hands up in the air before she does it. Right? And now we've got the little girl here getting her cup. Okay? And all right? And the reason this is called over-imitation, this was originally done by a guy named Derek Lyons. And now watch. Okay? It's called over-imitation is because what Derek Lyons had the clever thought to do, we had done a similar experiment before, like the one I showed you, but he asked them, is it necessary to do this to tear the rice over? And they say no. Well, then why did you do it? Well, that's just the way it's done, right? She told me she was going to show me how to do it. That's how you do it. Right? So this is conformity, normative conformity. This is the way you do it. Right? And then if another child comes along and does it without raising their arms, they say, no, you have to raise your arms. So this is where you get this cultural transmission of a special type, is the adults are teaching and the children are conforming and saying, you have to conform. This is the way it's done. This is the way you do it. Right? So it's got a force to it. It's not just, I prefer to do it this way. This is how you have to do it. Why? Because she showed me how, and that's how you do it. This is the game. Right? Nothing like this in other animal species. And now, just in case you don't believe me about this normative part, this is a third party. The child himself is not involved in this. We showed him a little game. And you don't need to know what the rules of the game are. It's not relevant. But he's going to roll a dice, and then something happens here. And the puppet is going to do it differently than the child has learned about the game. And you'll see what he does.
Oh, die Rose.
Die Rose ist richtig. Nicht dein Schuhe. Falsch.
Ich werde nochmal wachsen. Achtung, ich werde nochmal wachsen. Oh,
Okay. So this is a 3-year-old now.
Darf die Schule dieser Elefant?
She's trying to stay out of it. She's in.
Darf ich jetzt noch mal dachsen?
Ja.
Darf ich dachsen?
Der Elefant hat geschummelt.
Ist die gut dran, ne? Ich schreibe mal schnell was auf und lernen dabei weiter.
Weißt du, der Elefant hat geschummelt.
Just in case you're wondering, yes, people say, oh, you know, little German children are more pro-social and more normative than other children. But no, we've done this cross-culturally now, actually, in some close to hunter-gatherer cultures in Africa, as well as some in South America. And children in all cultures intervene when somebody's not, they learn the rules of the game are one way, and somebody plays it differently, they intervene and say, no, you can't play it like that. So this is also culturally universal. So this is, in the cultural learning, adults make sure children learn things, that's what teaching is, and the children want to conform, and not just prefer to conform, they feel like they have to conform because that's the way the things are done. So this leads to a kind of cultural transmission that is qualitatively different than just socially learning things from the way that other apes do it. Okay, so to wrap up here, let me just say that many aspects of uniquely human psychology evolved fairly recently. Now that depends on your time frame, but in the last million years or two, humans have been separated for 6 million years, so 2/3 of it. A lot of people claim they are just sort of bipedal apes. Their brains are the same, more or less the same size as apes. Everything's very similar. The last 2 million years or so, something different has happened. So that's fairly recently. I'm proposing it's something shared intentionality, working together with others in a we, both to coordinate with them and to pass on culture. And shared intentionality involves 2 sets of adaptations for mental coordination, one collaborating with individuals and the other group-minded cultural life and transmission. Notice that this is how you have to do it. This is how we do it, is a group-minded kind of thing. And these adaptations are fundamental to uniquely human processes. I didn't touch all of these today, but in various places I have touched on all of them. Uniquely human processes of cognition, communication, cooperation, and even morality. All of the normative stuff about this is how you have to do it, that's the sort of origin of the moral judgment of one ought to do this, one should do this, one must do that. And that's it. Thank you very much. Thank you. I understand a moderate amount of German, and I can get help if I need it. So if you want to ask a question in German, that will be fine.
Chimpanzees might have a theory of mind. It's verified by eye tracking, you know.
Yes.
Do you have a notion what they could use it for?
Competition.
Okay.
So, so here's so some people have proposed that they and humans get their theory of mind by competing, trying to figure out what the other guy's thinking so I can beat him. And that's theoretically possible. But the thing in coordination is I'm trying to facilitate you reading my mind. Right this minute, what's coming out of my mouth is me trying to help you read my mind. Right? That's what we do when we communicate. We advertise what we're thinking. And so I think that's the more likely place where the really high, complicated theory of mind stuff comes from, is when we're trying to coordinate and we're trying to help each other read each other's minds. So they have a kind of theory of mind for competition, and we have a higher order one for really social coordination in cooperation. Thank you.
I would like to come back to the cheating.
Yeah.
Because I was wondering, I mean, these three-year-old children, they need to get an idea what cheating is before they can identify things like that as cheating. And is the idea of cheating then not taught by their parents?
maybe cheating in rules, that may be possible, but the fairness thing I think comes naturally to them, that somebody's taking more than their share, if you want to call that cheating, that comes to them naturally. So in that one study you saw where the one kid gets 3 and the other gets 1, I didn't tell you about the control condition. In the control condition, they just come in and there's 3 on one side and 1 on the other side, and they almost never share, okay? I got my 3, you only got 1, all right, like that. So if you want to say that the parents have taught them that, you would have to say that their parents taught them, if you collaborate, you have to share fairly, but if you don't collaborate, don't worry about it, which I think is very unlikely. So I'm not trying to do away with parental influence. It's going to be very important. And in cheating in the rules of the game, they have to learn the rules, and at some point the parents have to tell them, you know, you can't do that, you're breaking the rules. But they generalize it to new games. We made up these games, and so they did it with a new game they'd never seen before. So they at the very least, they're generalizing to new places. And they use the normative language. This is the right way, das ist falsch, okay? Das ist richtig, and he's cheating. And so they may have seen something from adults, but they're applying it creatively on their own. And you can tell a chimp he's cheating all you want, and he's not going to get it. So they have some way, they have the capability of forming the concept. And maybe they need a little help from the parents, but they have the ability to form the concept themselves.
Is it necessary to control for the movements of the experimenters, because that might have an influence on these perceptive babies?
What we typically do is we have some kind of control condition, and I don't, in this kind of an informal talk, I don't always talk about the control conditions because that's kind of boring from a scientific, from a more.
So I take back my question.
So we often have control conditions where they are moving the same way, but they're not faced with exactly the same problem. Yeah.
I was wondering, how would you recognize the kickoff of the ratcheting in the archaeological record? Because certainly not every new invention is a kind of ratcheting, and if you look at the early records and you have the older one, not much happening over 100,000 of years, and then you have the Acheulean, and there's hand axes, okay, but not much happening over again 100,000 of years. That's not really ratcheting. And then later, well, if it comes to anatomically modern humans and the Upper Paleolithic, yes, I guess there we have ratcheting. So how do we identify the kickoff of ratcheting in the archaeological record?
That's a hard one. Again, we'll probably discuss that tomorrow morning. But the idea of ratcheting is that if a new individual came in and just saw the final product, they couldn't deal with it, right? You have to sort of gone step by step. Maybe I'm saying that the wrong way, because I was saying like children are just getting the new product. What I mean is, so let me start over again. In the culture would not get there if it didn't go through the middle step. The culture couldn't just go from one to the next. So if you just look at hafting, right? An individual has to be able to use rocks first before they would be able to think about putting a rock on a stick. It's sort of, you would think it would be required that you have to do that first. So you get there only when you've got some step in the middle. And so all you can do is look at things in the artifactual record that look like they are going step by step and that look like they require one for the next one. I mean, it looks like, in just a theoretical analysis, it would look like hafting a rock on a stick and pounding things with it depends on understanding that rocks break things up, and you've just found a better way to do it. So there's no great way is the answer to your question, but you would just look at the sequence and look at the likelihood of going from one step to the next, and the possibility of skipping a step. And again, that's mainly it's not fully empirical. That's true.
Thank you. I was wondering what is happening if chimpanzees grow up beyond humans, just have no contact to other chimpanzees. Does something change them?
Yes, people have done that. I'll first tell you an anecdote, and then I'll tell you a little bit of data. So back in the 30s, this couple named Hayes and Hayes, they got a little, they raised a little chimp along with their child Donald. And they slept in the same bedroom, they slept in bunk beds in the same bedroom, and they grew up together. And the idea was that the little chimp Gua was going to copy Donald and become more human-like. And at about age 2, Donald started going, and they decided they would stop the experiment because Donald was copying the chimp instead of the chimp copying Donald. But there are data, and we actually reviewed all the data in a paper, and the chimps who grow up around humans are actually a little bit better at social learning than the other ones are, and that's the main thing, is that they're more attuned to and so when the humans show them how to do something, they're better at learning it than the ones who just, and we proposed that it was really about social attention, that it's really about paying attention to things. When you demonstrate things for chimps, they're just kind of looking around and whatever. And you demonstrate something for a child and they're like this, right? And so when they're raised by humans, they become a little bit more attentive. But I don't think it leads to like this normative thing or to, this is the way it has to be done, or it doesn't lead to teaching or anything. But they do get to be slightly better social learners, yes.
On the other hand, isn't it like if a child grows up in the wild, then the child starts to have enormous problems with social behavior? Does that mean maybe that in very early years we are just very much blank? We are a blank book. Is that one of the strengths we have? This is why we can learn so well?
You're saying blank?
I would say so, because if we have
I mean, you could say that in some ways, but I think we come with a lot of evolved predispositions that would be expressed, even if we were raised. And there are these children that they, Kaspar Hauser and these kids, and there's a whole book about all the kids that were wild children or whatever. And it doesn't come to any definitive conclusions because a lot of times these children, they find them, the wild boy of Avignon, they find him coming in from the woods, but the proposal is that he was probably set out in the woods because he was autistic in the first place and that his parents couldn't deal with him. And Kaspar Hauser was abused. And so it's not really clear. They clearly have problems, but it's not really clear exactly what's the issue. And most of them learn some kind of language or something when they come later, and so yeah, it disrupts it a little bit, but we have a lot of evolved predispositions, and those evolved predispositions need to be exercised in social interaction and social learning and communication, and that's why the child on the desert island wouldn't get anything, but you can't ignore the evolved predispositions. I would just say that.
I wonder if you can briefly sketch the experiment or study that you mentioned that might show that chimpanzees can teach.
Yeah, it's not an experiment. That's one of the problems. One of the tensions in the literature is the people who watch them in the wild see things and interpret them in a rich way. People with an experimental frame of mind say, well, I can think of other explanations. Let's go do an experiment and see. So he made some observations. One set of them were quite reliable in the sense that they were replicable, that the mom, when she's cracking nuts, will leave the hammer there and go gather some more nuts and let the child use the hammer. And she wouldn't let another adult use the hammer. And he says that mom's trying to facilitate the child's learning. Maybe. Maybe she just trusts that the child's not going to steal it, and so she's leaving it. It's too heavy to carry or whatever. So you need to do an experiment. But then he had one anecdote where the mom seemingly looks at the child when she's hammering, and it looked like she's teaching him. But again, maybe the child made a noise and she's looking at the child. That's why you need experiments. You need to control everything, have a control group. It's not that I don't believe that he made those observations. They're not recorded on video, by the way. But it's not that I don't believe the observations. It's that any observation in the wild has multiple interpretations, and experiments are our best way. Experiments are artificial by definition, so when you bring it to the laboratory, maybe you're distorting the phenomenon when you bring it to the lab, but you're trying to reproduce the phenomenon in the laboratory and control, like the child's not making any noises, to make sure that that she is teaching him, or you have a control condition where there's another child there, not her child, or where there's an adult there, whatever it is. So anyway, I would just say that it was an interesting anecdote, but has not been followed up experimentally. So I typically wait till there's experimental evidence.
What is about antisocial behavior or like rebel behavior?
Yeah. Yes. Okay. That's a big. Tamara mentioned, sort of went off on that. People often ask me about that, and she. I don't know where you heard it, but my quip is often, if you think humans are not cooperative, you have the wrong baseline. You should hang around chimpanzees more and see some really non-cooperators. But human hunter-gatherer groups are extremely cooperative among themselves. It's almost like a big family. So they don't really have much by way of private property. They have some things, but not too much. They don't have, there are a lot of things that make it easier for them to be much more cooperative. And when we really start having these issues is with the rise of civilization and surplus that you have to protect, and stratified societies and in-group, out-group. We've got our stuff, those guys over there are threatening to us, and that happens. You start getting an in-group, out-group somewhere with modern humans, and then you really get the real difficulties with civilization and stratification and protecting the surplus. So if you look at most of the conflict in the world today, it's us versus them. They are threatening us, and we don't like it. Almost all the conflicts are framed in those terms. And I know it's a little bit silly, but I sometimes you say, guys in the mafia, they love their kids. They're fine. They're nice to their neighbors. Okay, they're in there. They have their group. Other mafia people. You can trust your mafioso buddies or whatever. In an army that's out to annihilate somebody else, they're cooperating in the group. They're trying to protect their buddies. So they're mostly cooperating in group. I mean, it's true you have rebels and stuff in groups, but for the most part, people are cooperating in groups, and the conflict is between groups. Now, in the group, one of the difficult parts since civilization is the elites, the rich, and the people that don't have much. Now you get conflict within the group because of these stratificational differences. And of course, you can have an individual fight over people who are just for the moment. But and the people that are really antisocial, we have a psychological classification for them, right? They're sociopaths, and sociopaths apparently don't really think about right and wrong. They don't really care about your feelings or whatever, and that's a pathology, and it's this 1% or something like that. So we can actually identify individuals who seem to have a biological deficit on this cooperation thing, and they are excluded. One of the things that makes them an issue is that they're good at faking it, but generally speaking, they're excluded from the goods of society. So yes, you can have antisocial individuals, but on the whole, humans are cooperative within group. And then the challenge for us in the modern world is that in our modern world, it's not even clear who your group is, right? I mean, you're in a lot of different groups. Every single group nowadays, if you think of a group as a nation state, they're all multicultural within the group. And again, you participate yourself in multiple groups. So in the hunter-gatherer day, in the early days, the groups were fairly distinct. And these are people that I know, and those are strangers over there, and we don't even speak the same language. And now it's much more complicated. And so that's really the challenge, that can our cooperative capacities, which evolved in small group contexts, can they scale up to the modern world? That's the challenge.
Yes, thank you, Michael.
Yeah.
Very excellent talk.
Yeah.
And also thank you for your interest. So fortunately, we're humans and not chimps, so we share our food. So please join us upstairs for food and drink and music and dance later.
Okay, great.